Okay, so we've talked about predicting amounts, we've talked about limiting reactants and excess reactants. Now we need to talk about what's called percent yield. Alright, and before we do that, we got to define a couple of things. Theoretical yield is the maximum amount of product that could be produced. And this is either given to you or you find with the chart or with dimensional analysis. Okay, so in theoretical yield, it's if every single atom and every single ion reacted, what would be the maximum amount of product that could be produced. Now, actual yield is what you actually obtain from a reaction. Okay, so this has to either be given to you or you're going to find it experimentally. And we're going to do this with a lab where we have to figure out exactly what the actual yield is. Okay? All right, now the percent yield is simply, oops, there's my little dots there. Percent yield is a ratio of the theoretical and actual yield. It represents the success of the reaction. It's very similar to percent error calculations that we've done when we're comparing something to a given. This time the theoretical yield is what how they should have come out to have been. Okay, so here is your equation. Percent yield is equal to the actual yield. This is measured in the lab or it is given to you. Okay, divide it by the theoretical yield. This is going to be calculated on paper or sometimes it's given to you. But this one is calculated, this one is measured. So we try to drive that point home because I guaranteed people will mess it up. And you also feel free to abbreviate it because this is another one where you have to write out the equation. So feel free to say AY over TY times 100 instead of writing that out every single time you solve a problem. Okay, so we got an easy one and then we got one that's a little bit more difficult. If you have not already done so, go ahead and take out a calculator as well as a periodic table. You're probably going to need both of them. Excuse me. Okay, so for number one, if the theoretical yield, I'll go ahead and write out the known and the unknown up here. Okay, theoretical yield, Ty, is equal to 1.13 grams of water, and the reaction actually produced. Now you got to think of some synonyms here for where it's not always going to use the word actually, it's not always going to say actual yield. So it may say produced, it may say collected, recovered is another one that's good for or used a lot for trying to tell you what the actual yield is, but it actually produced. So my actual yield of 1.02 grams of water. And they want to know the percent yield, or the unknown is the percent yield. Okay, so we're going to go ahead and set up the equation. The percent yield is equal to AY over TY times 100. We're going to use our data here. Even though I've trumped us in the past sometimes with percent composition to say 2 decimal places, we're going to use our data to determine our significant figures. So I have 1.02 grams over 1.13 grams times 100. Go ahead and solve this here. 0.02 divided by 1.13 times 100. I'm going to keep 3 sig figs. I'm going to get 90.3%, which I know a lot of people may go, ooh, 90%, that's great. And it's not really so great. In industries, they're shooting for like 99.99% yield. They want to get every single possible amount that they can. Okay, so we want to get, when you're doing percent yield, 100% yield is perfect. If you think all the way back to when we made chocolate chip cookies, not made them, talked about the recipe at the beginning of this unit, the recipe was for 5 dozen cookies. So if you got all of them, you got your yield. All right, let's look at another one. It says if 72 grams of C2H2 reacts with excess bromine. Now, I put this in here on purpose. Don't get confused when it says excess bromine. All they're trying to tell you is that the C2H2 is automatically your limiting reactant, and they're just telling you have plenty of bromine there. You're not going to run out, so you don't have to worry about doing anything extra. But you get 729 grams of product is recovered. What is the percent yield? Okay, so our known, this is a kind of a mixed problem because you got to do 2 steps here. We start with 72.0 grams of C2H2. We also know that, and here I put this on purpose, 72.9 grams of the product is recovered. So this is telling me This is my actual yield. When I ran the experiment, I only recovered 729 grams of this lovely compound. Yes, it's not a typo, it should be there. Kind of repeated twice. Okay, so CHBr2, CHBr2, okay? And then we have to find two things. We want to know the percent yield. Okay, that's absolutely correct. But before we can figure out the percent yield, we also have to figure out the theoretical yield. Okay, because they told me I had 72.0 grams of this. I got to figure out how much of that I'm going to make first, which is my theoretical yield, and then I can do the math. So let me come on over to a chart that I already have set up here. I think, yeah, I want to discard that. Okay, so here's my chart. I've already done and gone and plugged a couple of things in. Remember, for my chart, I've got grams, molar mass, moles, change, and X. You have to label those or I'm going to take points off. The reason why is that I know what order the chart goes into, but if you move on to chemistry and in college or later on and you try to do a problem this way and you don't tell them what they're labeled as, they may not be able to follow it. Not everybody teaches it this way, so you have to label those things. Okay, so what we do have, again, is, and I only have one column underneath these because I don't have to figure out how much excess is left. So that's why I only have one column underneath all of these. So I'm starting with 72.0, 72.0. I add an extra decimal place in there. Grams here. I already went ahead and found the molar mass, which was 2 carbons, and added it to 2 hydrogens, which is 26.04. Now, when I go down the chart, I'm going to divide. So 72, whoa, let me get out my calculator here. 72 divided by 26.04 is going to be, I'm going to keep at least 4 significant figures. Extra one is always safer, 2.7650. Because if you do this on your calculator, you actually get, I need to fix that, 2.76497. So we need to make that 2.7650. Again, one extra significant figure here. It's actually better if you can keep it on your calculator, but extra sig figs, because if you limit it too early, you will not get the right answer. Okay, my change, there's no coefficient, so the change is 1, so that's also the x value, 2.7650. Now, they told me I had excess bromine, so all that means is that this is automatically my limiting reactant, so this is the one I'm going to carry over here. So I've got 2.7650. Change again is 1. So my moles is also 2.7650. Remember, we divide going down the chart. Since we're going back up the chart, we're going to multiply. Okay, we've taken out the figuring out what goes on the top and what goes on. What I need to do on my calculator is take my 2.7650 and multiply it by 345.64. Okay, so that means that I am going to end up with 955 4 sig figs, because that's what we started with, 0.7 grams, and this is my theoretical yield. Okay, because that's what I was solving for. I was solving for the grams produced, and that was my theoretical yield. So now what I have to do is find percent yield. So if I look back to what they gave me before, or at least my equation for percent yield is going to be equal to, I'll just use this line here, AY over TY times 100. Okay, now they told me the actual yield in the last slide was 729 grams. Okay, my theoretical yield should have been 955. Actually, I remember I put an extra 0 here. So there were only 3 significant figures. So this one should have actually been 956. Okay, because that 7 would have rounded it up to 956. So I take this, I divide it by 956, times it by 100. So I take 729 divided by 956 times 100. I'm going to keep three significant figures because that's what I have. So my percent yield for this reaction is 76.3 because I get 76.25. So that means that I only recovered 76.3% of what I should have gotten. Now I do want to mention something. It is okay to get more than 100%. It doesn't necessarily mean that you did anything wrong with your math. It just means that there was an error that caused you to have a higher value of what you should have collected. Okay, I hope that helps, and we will do lots of more problems in class.